Hello and welcome back to my channel once again. It's Alan's Academy, your gateway to mathematics discovery. In today's tutorial, we want to look at plane geometry 2. We have been studying the theories and solving a lot of questions under plane geometry 2. In today's tutorial, I want to focus more of working some examples under plane geometry 2. So take your time and go through the video. Let's dive into it and we are off to go. We're going to take our first example. Plane geometry 1 is one of the topics that you need to go through because we are going to be using some of the theories there inside the circle theory. So this is example 1. It says a line AB is the diameter. So AB here is a diameter. A diameter is a line that divides the circle into two equal parts. So when you divide a circle into two semicircles, then that line in the center is what called a diameter. It's the connection of two different radius on a straight line. So it says that an angle CAB, where the angle 10 is 41 degrees. Calculate the angles X and Y and give reasons for your answers. So in circle theorems, all you have to do is to be able to master the theorems and to give reason to every answer that you give. Alright, so let's get into it. So they're saying that the angle CAB is 41. Now we've got to get angle X. To get angle X, so you have to apply the theorems. One of the theorems states that angles subtended from the diameter to the circumference of the circle. So when we say the circumference is the distance around the circle, that's the circumference. So any angle that is formed at the circumference, but it is subtending from the diameter, then that angle must be what? 90 degrees. So therefore, X here is 90 degrees. So X 90 degrees because angles in the semicircle is what? 90 degrees. That is when you divide this circle into two, that is diameter divides into two. It means that any angle that is formed inside here must be 90 degrees. It doesn't matter how it is trending, but it was 90 degrees. So when you tilt it anyhow, but that angle will definitely form what? 90 degrees. So angle C here is what? 90 degrees. Now, want to look for the Y, which is here. I just made mention that we need to use some properties in the plane geometry 1. So there's a property that states that angles in a triangle sums up to 180 degrees. So now we know angle CAB to be 41. We know ACB to be 90 degrees. Then we'll be able to find Y, because when I sum Y plus 90 degrees plus 41, this will give me 180 degrees. So it means that Y will be equal to 180 degrees minus 41 minus 90 degrees. In other words, what will I put here? That when I add all the three of them, it will give me 180 degrees. So therefore, Y is what? 49. Because when I put 49 here, 49 plus 41 will give me 90. And 90 plus 90 will give me 180 degrees. And that is how you find the value of Y. So just to illustrate, so we have 41 plus 49 plus 90, that will equal to what? 180 degrees. So when you add the angle here and that don't give you 180 degrees, you have to check your answer again. Now let's take the next example. Example 2. Here it's saying that work out all the missing angles in the cyclic triangle. So we have ACB, ABC, the triangle inside the circle here. And we have been given only one angle, which is the 46 degrees. But A, B, C, D, E is not given. And you have to look for it. But this is very easy if you have known the theories and the properties to use. So therefore, we have A to be the first angle we'll find. Now remember, any line drawn from the center of the circle to the circumference of the circle is a radius. A radius is the division of the diameter. So when you divide the diameter into 2, you get what? A radius. 2 radius gives you a diameter. So, but we're going to focus on this point. We are saying that any line drawn from the center to the circumference gives you what? A radius. So OC is a radius, OB is also what? A radius. And they are all on the same circle, which means that OB and OC are equal. And if they are equal, it means that angle A will be equal to this angle here, 46 degrees, because it's an isosceles triangle. This line and this line is equal, which means the base angle will also be what? Equal, considering the triangle COB. Take note of that. Now, angle CA is 46 degrees, which is coming from the isosceles triangle property. We got A, we can get B, looking at the property that will say that angles in a triangle sums up to 180 degrees. So we consider this triangle COB again. Now we know here to be 46, we know here to also be what? 46, because this angle is equal to this angle. And now I'll be able to get this. So what will I put at B? That when I sum 46 plus 46 plus B, it will give me 180 degrees. So you realize that when I put 88 degrees here, I'll be able to get it. So 46 plus 46 will give me 92 degrees. And 92 degrees plus 88 will give me 180 degrees. So it means angle B here is what? 88 degrees. So which means the reason you can give is that angles in a triangle sums up to 180 degrees. So I can take 46 plus 46 plus B equal to 180 degrees, and I carry the 46 plus 46 across the equal sign, it all becomes negative, and you take it from 180 degrees, then your final answer will be what? 88 degrees. Now that I have gotten 88 degrees, I'll be able to get C using the other property which states that angles on a straight line sums up to 180 degrees. So you can use your protractor and you try it. When you measure any straight line, you always realize it's what? 180 degrees. The protractor is a semicircle, it's a half circle. When you have two protractors and you put them together, it's formed a complete circle, which is 360 degrees round. But when you pick half of it, it's 180 degrees. So it means that half of it, when you measure any straight line from the center, it will always give what? 180 degrees. That's where that property is coming from. And so therefore, I'll pick 180 degrees minus 88 degrees, and I'll get C to be what? 92 degrees. Angles on a straight line. So C here is 92 degrees. But there's another property that states that's in the plane geometry 1. It says that two opposite interior angles is equal to one exterior angle. The sum of two opposite interior angles. So this is one exterior angle is outside this triangle, and the opposite is this and this. So the one that is closer is adjacent, but we are looking at the opposite. So the 46 plus 46 will give you 92. So you could easily use that property. Angles, opposite angles in a triangle sums up to what? One exterior angle. So that is the other property you can use to get your angle. So now we are looking for D. With the same property, OC is a radius, and OA is also what? A radius, which means this line here is equal to the line here. Okay, and if that's the case, I'll be able to find E, and I'll be able to find this. But we got here to be 44. Why? Because angles in a semicircle is 90 degrees. 90 degrees. So when I pick this plus this, I must get what? 90 degrees. And from our first example, we see that angles subtended from the diameter to any part of the circumference gives what? 90 degrees. So if you had known this place to be 46 degrees, then here will be what? 44 degrees. So that when I sum all of them, it gives me 90 degrees. So take note, you can pause the video and replay it and play it more. Now that's the angle D. Once you get the angle E at the last, which I just made mention that OA and OC are equal. So therefore, here is 44, here must also be what? 44, because an isosceles triangle. An isosceles triangle, the property states that the base angles are equal because the two lines here are equal. Alright? So E is also 44 degrees because it's an isosceles triangle. AOC is an isosceles triangle. So this is how you got this one. Now we're gonna take our next example. Now remember, all the focus is on what? The diameter here. So the diameter here is where all our property is coming from. So if you don't have the diameter here, you will not be able to apply some of those properties we have used. The diameter tells us that the angle subtended here is 90 degrees, and it tells us that this line OA is a radius and this is also a radius because this is a diameter, and tells us that this is center. Alright, so let's get our next example. This example says that we should work out the angle X and Y and explain how you cut your answers. Alright, so O is the center of the circle. O here is the center of the circle, and A, B, C, D is a cyclic quadrilateral. When we say a cyclic quadrilateral, what it means is that A, B, C, as A, B, C, D, this plane figure is a quadrilateral. It's a four-sided plane figure. Four-sided plane figures are called quadrilateral. And so it's a kite, you understand? It's a kite. And once a four-sided plane figure is inside a circle, then we call it cyclic quadrilateral. So the circle is the quadrilateral is inscribed inside the circle. Okay, so you're supposed to find the value of X and Y. So let's first get Y and we continue. Now there's a property that states that angle Y here is half the angle here. Angle ADB, that's Y, is half angle AOB, that is 130 degree. So when I divide 130 degree, I will get Y. So 130 degree divided by 2 will give me what? So let me, this one I'll use calculator. So 130 degree divided by 2 give me 65. So it means that my Y here is what? 65. Y is 65. Angle at the circumference is half the angle at the center. Alright? So Y is what? 65 degree. Now along with the X. So there's the property that also states that angles at the opposite side of the circumference sums up to 180 degrees. So it means that when I sum everything here plus this, you see 180. When I sum everything here plus here, it should give me 180. So if I know here to be 65, then I can find what? X. So to get X, we take 180 minus 65. So if you take 180 minus 65, what will you have? So I just want to know medicine, but I get 115. That's 115. 180 minus 65. Now give you 115 degrees. So it means that X is 115 degrees. Why? Again, we say the opposite angles in a cyclic quadrilateral add up to 180 degrees. Opposite angles in a cyclic quadrilateral sums up to 180 degrees. Okay. Now X is 115 degrees. The other way you could get this answer is also that the angle here is also twice the angle here, which means this angle is half of the angle formed here. So you could also find angle A, that's the angle O here. So if I'm to do that, just get the calculator. So we have, so the complete of this must give you 360 degrees. It's a circle, it's give you 360 degrees. So if I know it to be 130, now I'll be able to find here. So we have 360 degrees minus, so that's 60, that's the one, minus 130. And I got 230. And we are saying that the angle here is half of the angle formed here. And the angle formed here is 230. So let me divide it by 2. And you see that we have 115 degrees. So you can use the same property to also get it. And you can also use the property that says that the opposite angle in the cyclic quadrilateral sums up to 180 degrees. Take note. If you like this video, don't forget to give it a like, subscribe, and hit the notification bell so when I release any other new video, you will not be left out. Thank you very much. Let's continue. Now, we also have this example. It says calculate the angle A and B and give reasons for your answers. So we are calculating A and B here. Now, just like the property we just looked at, it says that the angle formed at the center is twice the angle at the circumference. So A here is half of what is here. So if A is half of this, I know that A should be what? 52 degrees. That is, if I pick 104 and divide it by 2, I'm going to get 52. So A here is what? 52, which is a reason that angle at the edge is half the angle at the center. The edge here is meaning the angle that is subtending to the circumference. Now, if A is 52, then B will also be what? Just look at it. It's just tilting at a different place, but the same thing. It's only moving to this side. It could move anywhere. So it means that B will also be 52, because same as above, the angle has just moved around the edge a bit. But there's a property that is still underlying this. The property says that angles subtended from the same chord, x and y, is a chord, to the circumference are equal. Take note. If they are from the same chord here, this and this will be equal. That is very important. It's a property we can be using in other examples. Alright? So take note and work it out. Mathematics is all about you taking practicals, and more practicals. I must be frank with you. No one is born to be a mathematician. So you all need to take examples and work them more and more. Feel free to put in the comment section if you need a personal tuition, and I will reach out to you. Thank you and have a nice time.